and welcome to STEMsational Women. I'm your host, Sage Amel, and in today's episode, we will be talking with the lovely Alicia Barber. Alicia is a current PhD student at Dartmouth, focused on biomarker and therapeutic development in Alzheimer's disease. She holds a Master of Philosophy in Translational Biomedical Research from the University of Cambridge and a Bachelor of Science in Neuroscience from Union College. Alicia is a contributing writer for Being Patient, a dementia-focused media company, and has been featured on various news outlets promoting policy reform and sharing her personal experience with Alzheimer's. With that being said, let's welcome Alicia. Hi,
Hello.
how are you?
Good. How are you?
I'm doing good, thank you. Glad that we could finally meet. This is amazing. I'm so excited.
Yeah, thank you. Thanks for having me.
Yeah, for sure. So we may as well just get started. The first thing I'll have you do is explain a little bit about your job or your field of research.
Sure. So my name's Alicia. I am currently a second year PhD student at Dartmouth, and I am in a neuroscience focused program. So I'm working towards getting my PhD in neuroscience, and my specific area of research is studying Alzheimer's disease. So I'm a translational biomedical researcher. I'm currently working with a mouse model of Alzheimer's disease, and I can go more into detail later, but basically we're working on testing a drug candidate and developing biomarkers for diagnosing AD.
Wow, that's amazing. That's super fascinating. My next question for you would be if you know of the approximate male to female ratio in your workplace.
So I was looking into this yesterday, and it seems like for academic science, there's a pretty even split between like graduate students, male versus female, actually like slight, I think it was 53%
Oh, that's pretty
female.
good.
But
Yeah.
then as you go up, like through career progression, it gets lower and lower of the percentage of women, specifically in academia. So it went from like 53% women in who are PhD candidates, and then it jumped to like 38% who were pre-tenure, like assistant professors.
Mm-hmm.
And then for a full tenure faculty role, it dropped to like 13% women, which I'm sure has to do with a lot of things. But, and that, of course, only accounts for one area of
For sure. Yeah.
science
Mhm.
careers. But that's definitely interesting to see as, you know, climbing up the ladder becomes harder and harder for women.
Yeah, so a little bit on that topic. So, studies have shown that in the fields of science, technology, engineering, and math, they've remained predominantly male. Again, it depends on, as you climb up and depending on what kind of level you're at. While the numbers of females involved in STEM are steadily rising, why do you think a gap like that kind of exists in the first place? And what would be some of your ideas on how to fix this?
Um, well, I think when you're looking at more like later in the final like competitive stages of a career, I'm sure it has a lot to do with society's view on bearing children and how that plays into someone's competitiveness or ability to progress career-wise compared to a man. So I think until we either have a paradigm shift on the importance and necessity of women taking time to have children and not seeing that as a downside or
For
a
sure.
weakness in women,
Mhm.
in addition to like providing more resources for women to have more support with their children and continue working, that is going to continue to be an issue.
Mhm.
But like I mean, it goes all the way back to children's age when I think just kind of some issues in the education system and how boys versus girls are treated, and how teachers kind of will focus more on one gender or the other in certain areas and not, or I think too, just like kind of culturally, one thing I'm seeing sort of more focus on is this like disconnect between femininity and intelligence or
Yes.
success in any sort of field. So people think that, if you see a woman who is really interested in fashion and makeup and like presenting herself well and more like feminine, girly type qualities, that seen as not being able to be associated with also
Yeah.
having a massive amount of intelligence and being able to be successful in
Mhm.
other areas. So that's one big thing too that I would wish to see,
Yeah.
these two areas not having to be, these whole separate.
Yeah. There's very much of a stereotype normally too. Yeah.
Yeah,
Which
and I
is
think that
unfortunate.
prevents the younger girls from being
Mhm.
able to see themselves as a scientist or any other STEM related profession, because they think like, oh, well,
Yeah.
I don't look like what
Yeah.
I'm seeing as a scientist, and like
Mhm.
I, want to go shopping. So clearly I don't want to, I wouldn't
Yeah.
be successful in this field.
Yeah, for sure. I know that when I was younger, I would go out shopping for clothes with my mom. And I've always kind of been very interested in science and math from a young age. But I'd go and I'd like take a glimpse at like the boys section for clothing. And this is like back when there was Sears and stuff. Um, and there'd be all these options for like, I love dinosaurs, but there's dinosaur shirts, stuff like science, math, all of that stuff that I found so interesting, but I couldn't find any of that in my section. And that was hard. Just, luckily I had like a family that supported me with that kind of passion. But it starts at a young age. It really does. Yeah.
Definitely. Yeah, that's a good point. And that's always something that irritates me with like what is made for like babies and like gender reveals when
Mhm.
like the girl is just like all these things like, oh, like glitter and
Yeah.
tiaras, and um there's just not as much of a focus
Yeah.
on the things like you mentioned. But I have seen this one company on like Facebook and stuff
Mhm.
that makes clothes for children that have like um, prominent like inspirational figures like
Oh, cool.
RBG, and like I think there were some
Yeah.
science ones and different things like that, like try and
Wow.
expose children and girls
Yeah, for
to those
sure.
types of people younger on.
Yeah, that's so amazing. And we need more of that, especially with the amount of people now getting involved. And I feel like even as, women in STEM and that's kind of gaining more exposure and attention as it should, I feel like, yeah, unfortunately there's still a lot to be done, especially from such a young age. Um, Speaking of that, my next question is what has been your experience at school? So, including way back in elementary school, high school, most recently university, and what has it been like regarding your passion for STEM?
Um, so I guess it's like far as I can go back, probably with most clarity would be high
Yeah.
school. So I definitely was not like a stellar science student in high school. I know I took like honors biology, honors chem, honors physics, and then like AP biology,
Mhm.
and um, they were always really a big struggle for me, and I just never felt like I found like my groove on like how to learn this information, and something just wasn't clicking for me. I'm sure it was a combination of myself and teachers and whatnot, but it would have definitely been really easy for me to be like, why would I ever continue on this path when I'm really struggling in these classes. Um, like AP biology, I took like either my junior or senior year, and it was just brutal. And that's like the one thing I wish I could, go back and share like where
Yeah.
I'm at now. It's a big difference, but I think in terms of high school, the one class I took that was like STEM related that kind of pushed me through was
Mhm.
um, an anatomy and physiology class my senior
Oh.
year. And I had just this great teacher, and it was this really cool like lab-based course. And that was kind of the first one. It was like really medicine focused and all about the different systems of the body and obviously anatomy. And I felt like I was able to really excel in that class, and it just worked for me. And that really gave me the enough motivation to say, okay, I'm not crazy to continue studying science. And then when I got to college, it was definitely a bit better, but there were still just like instances of like subtle moments of sexism, I guess. Like
Yeah.
I was pre-med for most of my time actually,
Oh,
before like shifting to more of a research focus.
right.
And like one time I um needed to register for physics. I was planning on taking physics because it was one of the like medical school requirements, and I couldn't get into the class, and I went to the physics like registrar, like
Yeah.
admin
Hmm.
office, and was asking about like, can I get on a wait list, or like how does this work? And um some like male professor came in and was like started talking to me and trying to see what I was doing, and he was like, oh well, like I doubt that like you're required to take physics, so like these spots will go to students that like actually need to take it. So just like things like that.
Yeah.
And orgo was a huge struggle for me,
Mm.
and I had to withdraw the first time, and then I had a new like advisor for college that because was originally a biology major, and then I ended up switching to neuroscience, which is what I do now. And so I had a new advisor, and I was meeting him for the first time, and I had um either the term before or something withdrawn from orgo, but I had previously done really well in like all of my biology courses. And
Hmm.
but he saw that I withdrew and was like, well, like clearly you just like didn't work hard enough, and like something's wrong, and like you should probably like reconsider your career path, and like something's wrong. So I was able to get a new advisor. But just small things like that looking back, it's like, oh well, that
Yeah.
is unfortunate, but overall it was a good experience for me in college. And I was able to just like learn a lot and have a lot of diverse experiences in terms of like research and healthcare and policy and different things. So that really allowed me to keep going towards graduate school, and I was able to meet some mentors that really supported me, thankfully.
Oh, well, that's good. Well, and that's incredible. That's what, the goal is. That's kind of what we hope for, right? Um, and then I was wondering if you could share some of your work or research or projects that you've been working on, and kind of your proudest achievement kind of to date.
Sure. So, one part of my path that I'm very proud of is that I have a master's degree from the University of Cambridge. So,
It's incredible.
I moved to England. Thank you. After I graduated from college, I um, moved to the UK and started doing research at Cambridge. And this was just like a huge achievement for me, and still is one of definitely my top ones, because
No
um,
kidding.
I really had to like to work very hard to get in, and it was just like such a unique process. And one of those moments where I just like made a decision that that's what I wanted to do, and then made it happen, which is always very fulfilling. But in addition to like more neurological or neuroscience specific diseases, I've also always really been interested in rare disease, just like any type of usually genetic condition
Yeah.
that affects a really small portion of the population, but often has an incredibly detrimental effect. And so I was in Cambridge, I joined a lab that was studying progeria, and that's always been something I was like oddly fascinated with. So progeria is like the main premature aging disorder where children have a certain mutation that causes them to age like 7 to 10 times faster than the usual person.
Mhm.
And so I was working with a woman at Cambridge who was starting research in that field. And I was actually more kind of focused on a sub project of a similar disorder called Cockayne syndrome. That's another premature aging disorder. And that was at that point kind of like my longest chunk of research, and kind of taught me the most about bench work. But it was just so cool to I was doing a lot of cell culture. So like you have cells that are from patients with these conditions. And it's a really cool feeling to think that, you're one of the few people working towards developing therapies or treatments for these diseases that are so rare. So that was a really cool experience for me. And currently, so like I said, I study Alzheimer's disease, and I have a couple different prongs of my research. So one is just that there is a big discrepancy between the number of men and women who get Alzheimer's disease. So I guess this is kind of now full circle again, talking about so women make up 2/3 of individuals with AD, and it was previously just kind of pushed to the side and thought that was because women have typically a longer life expectancy than men. Right. And so it was kind of just disregarded as like that being the reason. And then eventually there was enough evidence built and enough focus on it that showed that there are other biological reasons why women are more prone to developing Alzheimer's disease. So one of the areas of my research is determining like how estrogen influences like the health of your brain and the central nervous system, and how it influences the progression of Alzheimer's disease. And this is really linked like to menopause, because women have such a stark decrease in estrogen as they age and once they go through menopause. So, yeah, so that's kind of like one side. And then another related piece, I guess, to this is we're testing a drug candidate in mice that's sort of related to this like nuclear hormone type target. And so I have hundreds of these transgenic Alzheimer's mice that I've bred, and I treat them 2 times a week with this compound, and we're working to see if it has any effect on progression of disease or delay of developing of plaques and tangles and things like that. And then the third piece, finally, like I mentioned before, is focused on developing biomarkers for Alzheimer's disease. So one big issue, if among many, is that Alzheimer's starts to develop in the brain like decades before it's seen. So people think of AD as like a disorder that affects your grandparents, right? So it's older people, but that's usually the age when symptoms start, but it's actually more in middle life and like decades before that the pathological changes in the brain start to occur. So, and we're not able to really identify that, right? Because people are functioning fine. There's no symptoms. So it's really hard to study this like period of time where you're in this preclinical or prodromal phase where things are happening in your brain, but no one knows. So a big push is to develop biomarkers to give stronger indications that Alzheimer's is starting. So currently what is done is either you get a brain scan, a PET scan of your brain to see if they can detect like volume changes, some parts of your brain will kind of shrink, or you can actually see like the presence of plaques. And then they can also take out your CSF, or cerebral spinal fluid, from your spine, which is with spinal tap, which is not fun. And they can measure some markers of amyloid beta and tau as well. But so like I said, that's very invasive and
Yeah.
no one really likes to do that. And then PET scans are really, really pricey. So
Mm-hmm.
people don't like to do that either. So we're interested in kind of having it be more of a blood test would be ideal.
Yeah.
And there are some companies, there's like a one company that it's, I think it's either approved or waiting for approval, but like it's brand new where they can measure amyloid beta and tau in the blood. But we're looking to have identify some other targets apart from like just the pathological focus to incorporate. And so hopefully these types of markers would be able to be used early on to just start of indicate that something's happening in the
Mm-hmm.
brain and that might be indicative of Alzheimer's developing. They also could be used kind of throughout the whole journey. So it's kind of just this like unknown prognosis of like, well, it could be like 10 years or no one really knows like how it's going to progress in a person.
Mm-hmm.
It could be really slow, it could be really fast in some people. So it could kind of potentially give some information on how the disease is
Right.
progressing in people, if it's going really fast or slower. There's also some people like when they're older will have what they call mild cognitive impairment, where your memory's a little off and it's a little more than what you just expect from like being 70
Mm-hmm.
years old. But for some people this means that you're on your way to getting Alzheimer's, and for some you'll just kind of stay there in that lower zone.
Mm-hmm.
So potentially two of the markers could indicate if someone in this period is going to progress further to full-blown Alzheimer's, or if they're more likely going to stay in that mild area. So
Yeah.
there's lots of
That could be
potential ways to
huge.
impact.
Yeah.
Yeah, so those are kind
Wow.
of like my three main
That's so cool.
projects that are starting right now. So hopefully at least one of them will work out.
Yeah. Have you found that anything's been affected because of COVID at all?
Like for me personally,
Mm-hmm.
or
Yeah, like as far as
right
research and stuff goes.
right now I'm pretty much like full time in the lab, able to do most things.
Oh, that's good.
It definitely delayed kind of like my start because I joined
Mm-hmm.
the lab um last July. So it was kind of a slower like increments of me getting in and
Mm-hmm.
being able to really start. Um, but as of now, I'm pretty much able to function regularly in terms of research, thankfully. Yeah.
Yeah. Oh, that's awesome. Yeah, it's definitely I feel like a lesser talked about sort of field, which is interesting to hear that there's so much new research being done. It's so cool to me. My next question for you would be, I guess we sort of covered it, but what first encouraged you to even consider STEM as a possibility?
Um, I think my main like draw into
Mhm.
to STEM in general was I was just always very interested in disease, and I was initially like most fascinated, like I mentioned earlier, by these rare diseases, and it was just kind of mind blowing to me, and still is, that like you can have just the smallest single mutation, like one change, and it can make so many things go wrong. And on the other hand, like so many times people are fine. Like there's so
Mhm.
many things that have to go right. And just the biology of that, like I
That's so
find
cool.
fascinating. And just like how diseases develop. And so I was, like I mentioned also, that I was initially thought that that meant that I wanted to be um, a physician and, be able to treat patients and
Mhm.
interact with people who had diseases. And that was kind of my initial goal. But then I realized that, one, I became really interested in the brain. And I thought that like, wow, it's crazy that there's still so much about the brain that we don't know. And if there's like one burning question that I could like figure out or
Mhm.
spend my time focusing on, I think it would have to be understanding the brain and how it works, because it's just, in my opinion, like who we are is because of our brain. Like it is like my soul, I think, is my brain, and understanding that mystery is fascinating to me. So that, and then paired with my realization that like, wow, like there's so many diseases that, particularly those of the brain, that there's nothing that we can do for. Like, so if I were their physician, I would have like so few options to give patients. So like all of the like neurodegenerative diseases and pretty much mostly all neurological diseases and diseases of the brain have either no cure, no treatment option, or no treatment that has a really lasting effect. So I thought, well, that would be difficult to be a doctor and just say like, well, sorry, there's not much I can do. So that made me shift to thinking about, more the importance of research, and that if I were to go into research, then I would have a much more active role in actually trying to develop drugs and change the trajectory of people, and have kind of the ability to try and solve some of these problems rather than being on the end of not having many options. So that kind of was my main push to more of a research focus, and then that's what led me to decide to get my PhD.
Wow, I love that. That's so cool. So next question would be what's been one of the most rewarding parts about just being involved and a part of the career that you're doing right now?
Well, I guess I also have a very personal attachment to Alzheimer's disease. My grandmother has Alzheimer's, and she was diagnosed about 5 or 6 years ago while I was a senior in college. And she's definitely been kind of like a big push for me in terms of neuroscience and that being my focus. And kind of like how I mentioned earlier, how I think your brain is just like who you are. And I kind of got to see that firsthand where, she's like slowly lost most of the pieces of who she is because her brain is no longer functioning properly because of this disease. So it's rewarding for me to be able to try and in real time have some active role in, if not helping her, but helping others who can and will develop this disease. So that's probably one of the most rewarding things for me, is just although it's often a very still helpless feeling, but being able to feel like I'm doing something and I'm on the side of trying to one day make it so that there aren't families rattled by this horrible disease.
Yeah, for sure. And like you said, it's nice to have a little bit more of an active role in it too,
Yeah.
And then who have been some of your role models throughout like your career?
So one person right now, this woman that I'm think is super cool. Her name is Dr. Lisa Mosconi, and she works at Weill Cornell and is a neuroscientist. And she's like a huge pioneer in this like push to focus on women's brain health, and kind of what I spoke to earlier of how women are more prone to Alzheimer's disease, and how it was for so long just like disregarded. And she's super cool, and she is like the head of the Women's Brain Initiative at Weill Cornell, where there's all these clinical trials being done, specifically trying to understand more about like how women's brains work, and if there's like any things that can be done to she really focuses on like prevention. And she has a few books that she's written. One is the most recent one, like the XX Brain, that's about like things that why women are more at risk and things that women can do to try and mitigate that risk, like through diet and lifestyle and like stress. And stress is a huge piece that really plays a role, particularly in women who just like take on all the stress. But she's really cool. And I'm also really interested find like biotech and like health tech type companies really cool. And so I guess one is Deborah Kahn, who I actually work with. I am a contributing writer for a dementia-focused news site called
Oh,
Being
wow.
Patient. And Deborah is the founder of that company, media company. And it's basically just like a news website, but like every article is about Alzheimer's and the brain. And
Mm-hmm.
her mother was diagnosed with Alzheimer's, and she wanted to like create a place to for someone to be able to go and like find everything they need and like not have just have like factual, like
Yeah.
unbiased and she does a lot of interviews with like leading clinicians and scientists to like give people access to what's happening in terms of research. So
Mhm.
I think that like science communication is a huge
Yeah.
piece and something I'm really interested in. That's just important on all fronts, but in terms of dementia as well. And another woman, her name is Nancy Yu, started this company. It was originally called RDMD, and it's now called All Stripes, and it's a rare disease focused health tech company where they have like a handful of different rare diseases that they're interested in, and they kind of I think say that they are like a bridge between pharmaceutical companies and patients,
Okay.
and they get access or given access to all these different, so like if a family member or like say a mom sees that they're interested in this one disease that their child has, they can give the company permission to access like all of their medical records from like every doctor, and they're able to pull out data like from blood
Oh,
tests
interesting.
or anything that they can track like through all of their records,
Yeah.
and then provide that information to pharmaceutical companies for them to have um, to either like build a case to try testing a drug for that disease, or to have a better understanding of like what the natural disease progression is, so that when they're testing their drug, they could potentially compare it to that rather than giving patients a placebo. So
Right.
I find it really fascinating too, like apart from just research, like there's so many things that can be done um, in terms of like technology and communication that can really improve like the whole spectrum of health and
Yeah, no
science
kidding.
rather
Yeah.
than just developing a drug. There's so many things that like in the meantime that I think can um, improve how things are done and what people know.
Yeah, for sure. Yeah, that's amazing. Um, so looks like we're kind of nearing our time right now. So the last question I'll have for you before we leave is if you have any advice for girls and women who want to or who are trying to get involved in STEM.
I think my main advice for this question is always to just like never give up. Like there are so many roadblocks that you'll hit. Um, and it's just so important to not let others or like your own mind tell you that you should quit or stop, or that like you're not smart enough, or that like there's this idea of like imposter syndrome and not feeling
Yes,
like
yes.
you're like in the right place or that you deserve to be where you are. It's something that I continue to face, where I'm just like, what am I doing, like how am I here? But like you know trying to prevent those feelings and like not letting others tell you that you can't pursue science, or that you're not going to be successful, or that
Right.
it's not for you, to just um, if it's what you want to do, to just focus on those larger end goals. Like it's always pushes me to just think about like the impact that research can have on patients and people in the world. So just like pushing through the moments of feeling inferior or inadequate, and
Mhm.
just thinking about what it could do, and that every single person joining the force of STEM is like one step closer to potentially solving
Yeah.
so many problems.
That's incredible. And that's such an important message for everyone, not even just girls and women, but just anyone in general who's trying to kind of get into that field or who's unsure, that's pretty important.
Definitely. Yeah, it's hard growing up and like working through any career path, no matter what it is, but it's definitely important to just keep going and push through and, make sure that you have um, support systems in place to go to when you're feeling that way is very important. But to just say, okay, I'll figure this problem out too. Like it's just you learn, I think, as you go too, like that. Once you've faced so many things that you're like, okay, well, like what's
What's
one
one
more?
more?
So
Yeah.
yeah.
Yeah. Oh, well, thank you so much. I'm so glad that we could have you, Alicia. That it's been amazing, and we've gotten some really cool insight. So I'm glad that we could have you, and I hope you have an amazing rest of your day.
Thank you. Yeah, this was fun. Thank you so much for having me. It was great to talk to
Thank you.
you.
Bye.
Bye.